Good morning, Year 6. It is time for your lesson today. So we are learning to calculate the volume of a shape. Now this is something new to you in Year 6, looking at the volume of the shape. Now over the last week we've been looking at the perimeter of the shape, and we've been looking at the area of the shape. These are the two things that we have been looking at to do with shape over the last week or so. Remembering that perimeter is the distance around the edge. That's what's important with that. And the area, what can you remember what the area is? It's the number of squares. It's the number of squares in a shape. So these are the two things we've looked at, and today we are looking at volume, the volume of a shape. Now volume might be a word that you've heard before when you think about sound. Turn up the volume, turn down the volume. It means something different within maths. The volume is a bit more to do with capacity. Now you might have heard about volume when we've talked about it in science. The volume of something specifically to do with liquid. Liquid is measured in volume, and we will be looking at volume in a little bit more detail today. So what is volume? So volume basically is the number of cubes within a shape. Okay, so area was the number of squares within the shape. Volume is the number of cubes within a shape. Okay, so we need to change our focus and thinking from last week with perimeter and area. The shapes were 2D, they were in 2 dimensions, whereas volume, we're looking at 3D shapes in 3 dimensions. Now 2D shapes are shapes that are completely flat. The only side they have to them is the front one, the front face, whereas 3-dimensional shapes are shapes that you can pick up and manipulate and turn around, the number of cubes in a shape. So the best way that we can look at these in Year 6 is thinking about these. Multilink got absolutely loads of these in school. These are cubes, you can see. Each side is the same length in here, number of cubes in a shape. If you think about a dice, that's a perfect example of a cube. So volume is measured in these, it's measured in cubes. Whereas when we looked at area, area was simply squares, 2D. Whereas volume, 3D, we need to have a think, don't we, about it being 3-dimensional, being able to see all the different faces, the 6 faces within it. Okay, so let's have a look at how we calculate the volume, because it's actually not as difficult as you might think, because even though a 3D shape is more complex than a 2D, it's not as difficult as you might think. So let's have a look at some shapes. So first of all, if we have a look at this shape here, you can see I've made it out of Multilink, and if we were to look at the number of faces, you can see it's got 1, 2, 3, 4, 5, 6 faces. You can see the edges, but you can see that it's a 3-dimensional shape, a shape that can be picked up and moved around and manipulated. So if I was to put this shape on here and we were to look and see how many cubes this shape has, what I can do is I can count them like this, can't I? I can go 1, 2, 3, 4, 5, 6, and then I could just turn it round. 7, 8, 9, 10, 11, 12. So there are 12 cubes within that shape. Now, if these were centimetres, they're not centimetres, but if the unit of measurement was centimetres, just like when we've done perimeter, and just like when we have done area, we need to write the unit of measurement. I'll write that a bit closer. So imagine it was centimetres. What unit of measurement we've got centimetres. What do we think I'm going to be putting here? Remember, for perimeter, we didn't put anything. Then for area, we put squared. For volume, remember, it's the number of cubes. Remember, we've looked at cube shapes before when we did BIDMAS, and we looked at square and cube numbers. It would be the cube symbol we would write here. 12 centimetres cubed. Now, obviously, we can't always have a shape here that you can pick up and turn around and count the cubes in, because more often than not, you're going to have it drawn on a piece of paper and you've got to try to work it out. And in that case, you can't pick it up and count the actual cubes like I have here. But the way that you would work this out, the formula, if you like, for working this out is this. It's the base, which if you look at this here, the base would be this line along here. If you times it by the height, which is this one here, and then if you times it by the width, which is this one here. So base times height times width would tell you that. So if we have a look at this, how many across is the base? It is 1, 2, 3. The base is 3. How many is the height? It is 1, 2. How much is the width? Again, 1, 2. So to work out the volume of the shape, it's 3 times 2 times 2. It's kind of like a BIDMAS question here. So if we were to do 3 times 2, which is 6, and then 6 times 2 gets us to our 12. We could do it in a different way. We could do 2 times 2, which is 4 times by the 3, which is 12 again. It doesn't matter which order you do the multiplication in, you will always get to the same answer. But remembering the formula is base times by height times by width. So we've got the base, the bottom of the shape, times by the height, times by the width. And I could turn it round like this, couldn't I? To turn this into the base, this into the height, and this into the width. It would still be 3, 2, and 2 to always get to 12. And we actually counted how many cubes there were in that shape to prove that it was 12. So let's have another look. I will rub these off, but remember the formula for volume stays the same all the time. Base times height times width. So if we look at another shape here that I have. Now, what I'll do first of all, again, I will count the squares, the cubes in here, and we will see if the answer is correct when we calculate it in a moment. 1, 2, 3, 4, 5, 6, 7, 8, and I can turn it around. 9, 10, 11, 12, 13, 14, 15, 16. So I know my answer here is going to be 16, and let's go with centimetres again. And the cube symbol again, that's the number of cubes. I know there are 16 cubes in here. I could break this apart and count those cubes individually, and I would definitely have 16 because I've just counted them. And you can't do that with every single shape to pick it up and count it and manipulate it, but we can use the formula to prove it. So if I was to hold it like this, now the base is across here. So if I was to draw on this again, we can see, can't we? It is 1, 2, 3, 4. The height is 1, 2. And the width going back this way is 1, 2 again. So all I need to do is multiply these numbers together. So if I do 4 times by 2 is 8, then take our 8 and times it by 2, gets to 16. Or we could do 2 times 2 is 4, times it by the 4 is 16 again. Base times by height times by width. Okay? Because we can see here, can't we? Within here, we've got 8, 4, 8. So that half there, we can see, is 8. That's why we've done 4 times by 2 to get to our 8. And there are 2 of them. 4 times by 2 is 8. Bring them together, that's how we get that width there. 4 times 2 times 2. Right, let's have another look at the multi-link again. Now we have this one here, it's a larger one. Now with this one, I could begin to count all these. However, there is a cube inside that I can't count. I can't see it. So we need to rely, in this case, on this formula, base times height times width. So we can see here, the base, just dropped one, base is 3. The height is also 3, 1, 2, 3. And the width is 1, 2, 3 as well. So it's 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. And if we say centimetres again, remembering that cube symbol, 27 centimetres cubed. Now, I could break this apart now and I could begin to count these. So we can see that is 3 times 3, that's 9 here. 3 times 3 again, that's 9 there. 3 times 3 again, that's 9 there. So you can see it's 3 lots of 3 times 3. That's how you get to 27. There are 27 cubes within this shape here. Okay. So if we were to move on and have a look at another shape. Now this is much more close to the type of question you would have been given. So if we are to look at this, the base, again, is the same formula. Base times by height times by width. Now I've done these in different colours. The base, you can see, I've done in black. The height, you can see, looking at here, I've done in pink. And the width I have drawn in blue. Those 3 different colours I've used. Now, all of these black lines are the same length. They're all 10 centimetres. All of these pink lines are the same length. They're all 4 centimetres. And all of these blue lines are the same length. They're all 5 centimetres. So you can see it's a 3-dimensional shape. So the base is 10 centimetres. The height going up here, doesn't matter which one of these 4 lines I choose, is 4 centimetres. And the width, we can see, doesn't matter which one we choose, but let's choose this one, is 5 centimetres. And the way to calculate that would be to multiply these all together. Now remember what I said, it doesn't matter which order you multiply these in, you will all get to the same answer. So what I would recommend is, particularly because it's got a 10, is if you multiply 5 by 4 first of all, which is a nice easy one to get to 20, and then have 20 times by 10 to get us to 200 centimetres cubed. Okay, now we could have done 10 times 4 to get us to 40, and then had 40 times 5 to get us to 200, but that was a bit more straightforward, wasn't it? Or we could have done 5 times 10 to get us to 50, and then 50 times 4 to get us to 200. It doesn't matter which order you do these in, you will always get to the same answer as long as your multiplications are accurate. So can you see here how if I was made this with a multi-link, it would have been, not only would it have taken me a long time, it would have been incredibly difficult to have got an accurate answer, because I would have had 200 cubes within this shape. But if you're remembering, base times by the height times by the width will get you to how many cubes there are within that shape. Okay, so we will have a look at one more. Do you think you could have a go at working out what the volume is of that shape for me? Yes, you might have to pause the video there, remembering base times by width times by height. Okay, so base is 5, then times by width, which is 4, times by height, which is 3. It doesn't matter which order we do this in. Let's do these first, this one first of all. 5 times 4 we know is 20. 20 times 3 is 60. The unit of measurement is centimetres, the number of cubes in the shape, so we write the cubed symbol there. Okay, let's have a go at this shape again. And I will write some more out for you to have a go at. So let's have 10, let's do meters this time, so we're not always doing centimeters. Let's make this one 5 meters, and let's make this one 3 meters. So imagine maybe this is a swimming pool. It could be a really big swimming pool, working out the volume of that swimming pool. So you might have to pause the video there, year 6, have a go at working it out. So remembering it's very easy to multiply by 10, isn't it? So I think it's probably best in this case to multiply the base, the height and the width first of all. So 3 times 5 we know is 15. 15 times by 10 is 150. So this would be 150 meters cubed. We could have done 10 times 5 to get us to 50, 50 times 3 to get to 150. We could have done 10 times 3 to get to 30 and times it by 5 to get to 150. Doesn't matter which way you multiply them, as long as you do multiply the base times by the height times by the width. Right, the final one that we'll do for today, if this one was 12, let's do meters again. If this one was 12 meters, if this one was 5 meters, and if this one was 2 meters, do you think you could have a go at working what the volume of that shape is for me, year 6? Okay, so remembering it is base times by height times by width. Doesn't matter which order you do those in. So let's do 2 times 5 first of all, because we know it gets us to 10. And then let's take this 10 and multiply it by the base. 10 times 12 is 120. So it'll be 120 meters cubed. You could have done, first of all, you could have done 5 times 12 to get to 60 and double it to get to 120. You could have done 2 times 12 to get to 24 and then times it by 5. Doesn't matter which way you do these, as long as you multiply the base by the height by the width. So have a go at these questions on the worksheet, year 6, remembering base times height times width, and send it back to your teacher. Thank you.